Hi all, this is Disha Shukla and welcome to the session. In this session, we are going to discuss about digital data analog signal modulation. This is the third type of modulation. The first we saw analog data, digital signals, analog data, analog signals, and now it's the third type, that is digital data, analog signals. Now, seeing in detail, digital modulation provides more information capacity, high data rate security, quicker system availability with greater quality communication. Hence, digital modulation techniques have a greater demand for their capacity to convey large amount of data than the analog modulation techniques. There are many types of digital modulation techniques and also their combination depending upon the need. Of them all, we will discuss some prominent ones here. The first one is amplitude shift keying. Now, amplitude shift keying is a type of amplitude modulation which represents the binary data in the form of variation in the amplitude of a signal. Now, as shown in the figure, you can see that the digital signal is a 0-1 volt signal and the ASK modulated signal shows 1 volt positive and negative -1 volt for the values where the digital signal has a value 1. And for the signal when the value is 0, we have a 0 potential even in the ASK modulated. So this is how amplitude shift keying amplitude shift keying modulated output looks like. The another type is the frequency shift keying. Now, frequency shift keying or FSK is the digital modulation technique in which the frequency of the carrier signal varies according to the digital signal changes. FSK is a scheme of frequency modulation. The output of a FSK modulated wave is high in frequency for a binary high input and is low in frequency for a binary low input. The binary ones and zeros are called the mark and the space frequency. Now, as you can see, when the value is 0, we have a 0 value. But when the value increases, that is from 0 when it goes to 1, the frequency in the FSK modulated signal increases. Again, when the value decreases from 1 to 0, the frequency of the FSK modulated signal decreases. So this is how a frequency shifted key output modulated looks like. The third type is the phase shift keying. The phase shift keying is one kind of digital modulation method. This kind of method is used to transmit the data by modulating, otherwise changing the phase of the carrier signal, which is known as the reference signal. The digital data can be represented with any kind of digital modulation method by using a limited number of separate signals. This kind of modulation method uses a limited number of phases where each phase can be assigned with the binary digits. Now, as you can see in the figure, for the when the value changes from 0 to 1, the phase of the PSK modulated signal is shown. Now, when again the value changes from 1 to 0, the phase of the signal changes accordingly. Again, from 0 to 1, the phase of the signal is inverted. This is how a phase shift keying modulation works. The other types of phase shift keying are again they can be customized, and the one is binary phase shift keying. Now, the term BPSK stands for binary phase shift keying, and sometimes it's also called as a PRK, that is phase reversal keying, or 2PSK. This kind of phase shift keying utilizes two phases which are separated with 180 degrees. So this is the reason to call it a 2PSK. This type of modulation is strong to all the PSKs as it takes the maximum level of the noise, otherwise to distortion to make the demodulator attain an incorrect decision. Here, when the value changes from 0 to 1, the phase changes from +1 to -1. That is the whole the whole phase changes from +1 to -1. So it is changing the two phases. So that is why it is called a 2PSK. Moving forward, it is the 4PSK. Now, that is the quadrature phase shift keying. The bit rate can be enhanced by adding more bits on one single segment. This kind of PSK, the bit stream can be parallelized so that every 2 incoming bits can be split up and phase shift keying of carrier frequency. One carrier frequency can be phase shifted with 90 degree from the other within the quadrature. Then the 2 phase shift keying signals are added to generate one of the 4 signal elements. As you can see in the figure, the phase is shifted by 4 times. That is why it's called a quadrated phase shift. Now as you can see here, the signal is ending here. That is, the 2 bits are ended at 0010, and then the phase is changing. So that is why the whole signal is changed by 90 degrees and then again it is changed by 90 degrees, and hence it is called a QPSK, that is quadrature phase shift keying, that is phase shifting by 4 times. So this is all about the different shift keying techniques, that is your ASK, PSK, FSK, BPSK and QPSK. Now if you have any questions in this, you can contact me. Till then, keep learning.